See, today we're discussing about the topic is optical fiber. Optical fiber. See, this is the one of the application of total internal reflection. Application of total internal reflection. See, the optical fiber is a transmission of medium. So what is the optical fiber is a transmission of medium to carry optical signal, to carry the optical signal without any loss of its optical signal. It can be carry of the without any loss of optical signal. See, that is called as the optical fiber. That's a main in the principle we say here. See, it's a principle. It is working on principle of total internal reflection. It is working on principle of total internal reflection. Now see the construction. What is say the optical fiber? Optical fiber is nothing but without loss of energy can be traveling one end to another end. That is called as the optical fiber. That is called the optical. Nowadays we can using of this optical fiber in a telecommunication. Telecommunication, because of observing in telecommunication, the number of signals are there, but there is no loss of energy can be traveling one point to another. See, using of this optical fiber. See, we are discussing about the construction. What are we discussing about the construction? See, optical fiber is a very thin fiber, very thin fiber, and its radius the approximately 10 to the power of minus 6 meter. 10 to the power of minus 6 is nothing but 0.00001 meter. That means the very less of the radius is constrained by this optical fiber. Now this optical fiber consists of three parts. How many parts are there? The first one is say the core, and second one say the cladding, and third one is say the buffer. Core, cladding, buffer. Now see, this is the diagram. So this is the first one is say the core. The first one is say the core, and is around the core of around what is taken by this cladding. Now the cladding is around what is there here, the buffer. The buffer is nothing but the protection of core and glass cladding. The protection of the core and cladding is called as the buffer. Okay. See, now the individual we discussing about this one. First one we discussing about the core. Core is made of glass. The way to we can made of is the made of in a glass. Now its refractive index 1.7. Its refractive index is the 1.7, and it act as a denser medium. It act as a denser because of it's made of with a glass. The which made of is there glass. So glass is nothing but is the which of the medium can be acting by the denser medium. Can be act as a denser medium. The next one is there cladding. See, the core is surrounded. The core is surrounded by material. As called cladding. See, the best example we take the marker. See, this is a point. This point is indicating by the core. The point is indicating by the core. Is around. See, this a blue will be there. That is called the cladding. This is called the cladding. And after that, what is there? This is a white is there. This white is considered the buffer. This buffer is nothing but the protection of this blue and this black ink. See, that is also say here the now the cladding. Cladding is nothing but what is the core is surrounded. The core is surrounded by a material called as a cladding. Now its refractive index. How much is there here? The 1.5, and it act as a rarer medium. It act as a rarer medium. The next we discussing about the buffer. See, the external protection of core and cladding is the surrounded by a material as called buffer. అంటే బఫర్ అంటే ఏందన్నా మనకి ఈ కోర్ను క్లాడింగ్ ఇస్ సరౌండింగ్ అంటే రెండింటిని ప్రొటెక్షన్ చేస్తూ పైన ఉండే భాగాన్ని ఏమంటారంటే ఇట్ ఈస్ కాల్డ్ యాజ్ ద బఫర్. సో బఫర్ ఈస్ జనరల్లీ మేడ్ ఆఫ్ plastic. The buffer is the generally made of plastic. Now we can discussing about the working of optical fiber. We're discussing about the working of optical fiber. Now this is consider the inside of a optical fiber. Inside of a optical fiber. Already we see the core and cladding and see the buffer. See that is the inner part. Inner part we can draw by there. See this is the upper and this is lower. Here is constructed by the core. What is you can construct by this core? This is constructed the core. This is constructing a core, and this is called as the cladding. This is called as the cladding. Now when a ray of light is instant on its core. Instant on a core. Now it's normal. You can say this is a normal. This angle is called as the angle of incidence I. After that, the light can be traveling from rarer medium to denser medium because of its entering into the denser medium. And now we can the refracted and metered the cladding. The way we can be meeting by this the metered the cladding. Now here you consider the normal. Now this angle of incidence we consider the I1. This angle of incidence is greater than of critical angle. This angle of incidence is greater than of critical angle because of the where the meet this position interface of core and cladding. Here the interface of the core and cladding. This is the core and it will be the cladding. We know the formula. We know the refractive index core. The core of the refractive index is there 1.7 and cladding. The cladding of refractive index how much is there here? The 1.7. That means the critical angle, the cladding of the refractive index is more the compared to the core. That's why the angle of incidence is greater than of critical angle. The angle of incidence is greater than of critical angle. Then the light can be reflected into the same medium. The meet at the another point. Another point. Now this is the normal. This angle of incidence is considered I1. And after that, this light can be again is reflected because of again here the angle of incidence is greater than of critical angle. Greater than of critical angle. And this can be meet at the another end of the finally it can be the moving away from a this optical fiber. See here when I enter into the light, the which of the energy is there, the same energy too is coming in out of a optical fiber. That means there is no energy loss. There is no energy loss of a this light. See this is called as the optical fiber. Or also we say that when for example the energy replaced by this is a signal. The signal is enter into any the optical fiber and finally coming out of this optical fiber also there is no loss of any signal. There is no loss of any signal is considered. This is called as the working of a optical fiber. When a light or signal in the form of light is directed at one end of the fiber. This is the one end of the fiber. It is shootable and it is undergoes the repeated total internal reflection along the length of the fiber and finally comes out at other end. Due to this total internal reflection, there is no loss of intensity of light. This is the working of optical fiber. Now the uses. Main uses of optical fiber. The first one, the optical fiber sensor are used to measure temperature and pressure. And second one, the optical fibers are used for measure the blood flow in the heart. Now third one, it is used in telecommunication, endoscope, and laparoscope. See, this is the main uses of a optical fiber.